Alright, let's do number 2. Write an equation with the following information. A cubic function, so I'm thinking of something to the third power, with x-intercepts of 1, 0, negative 1 half, 0, 1/4, 0, and a y-intercept of 0, 2. Let's give ourselves a visual to see what's happening. I see a bunch of fractions there. So I'm going to count this as 1. So if you have $1 there, then this is 1/4, 1/2, 3/4, and 1. So if I graph these, let's see what I got. I have 1, 0. I have negative 1/2. I have 1/4. 0. So again, each of these are 1/4 or a quarter. And then I have a y-intercept of 0, 2. On my scale here, I'm going to make this 1s. And I'm going to note that by putting a 1 here. So you'll notice that these are 4 boxes equals 1, and going on the y-axis, I chose that. And all we're doing here is just giving ourselves a quick sketch or an idea of what's happening. Cubic functions are odd degrees. So the easiest odd degree you could think of is x to the first power. That kind of looks like this. Starts down, ends up. That should have been a straight line. So I think my graph's going to look something like, we don't know yet, but well, I do know. It's going to look like this. So the goal is, how do I write an equation for this? Well, we do know something about what it's written in. It's written in something called factored form. Factored form just basically kind of looks like this. F of x equals a times x minus p, x minus q, and then, I don't know, think of another letter, x minus r. And basically what's happening here is each of these values here so that negative 1/2 will eventually go here for my q. And the 1 will go here for my p. And the 1/4 will go here for my r value. So I'm going to have something like this so far. We're going to leave the a value. I'm going to change the f of x to a y, so that makes it a little bit easier for us. So there I have my p value, which is a 1, x minus negative 1/2. Remember, there is a minus sign in our factored form. X minus 1/4. Okay, now I'm going to use this next puzzle piece. So I've used 1, 0, I've used negative 1/2, 0, I've used 1/4, 0. Now I'm going to use the y-intercept. The y-intercept is essentially a pair. It's an x-y coordinate. And basically it says every x value we're going to put in 0. And every y value I'm going to put in 2. So let's go ahead and do the substitutions. And basically what we're doing here is we're solving for the a value. So I have 2 equals a times 0 minus 1. And notice here you have 3 x's. So every x value you're going to put in a 0. This is the opposite of negative 1/2, which is positive 1/2. And then 0 minus 1/4. And then basically what I'm going to do is I'm going to solve for the a value by simplifying all of that, get an a value, and then we're going to put it back right here, and that gives us a cubic equation. So 2 times a, 0 minus 1 is negative 1, 0 plus 1/2 is 1/2, and 0 minus 1/4 is negative 1/4. Now I'm just going to multiply those. Negative times a positive is a negative. Negative times a negative is a positive, so I know my answer is a positive. 1 times 1/2 is 1/2. 1/2 times 1/4. There you're just multiplying across numerator and denominator. You're going to get 1/8. And then to solve for a, I'm just going to multiply both sides by the reciprocal there. So that would be 8 over 1, or basically I'm multiplying both sides by 8. The reason why I do that is this becomes 8 over 8, which is just 1, or you can cross cancel and that's 1. So you're left with 16 equals a. Do I have any more colors? Oh yeah, purple. So with an answer of a equals 16, I can come back up here to this original problem and just basically put in 16 there, and that's what I'm going to do. So my answer is y equals 16 times x minus 1, x plus 1/2, I can simplify that, and then x minus 1/4. Another way of writing this, so this would be completely fine. Sometimes they don't like fractions there. So what you can do is let's just say you eventually would set this equal to 0. So x plus 1/2. So I'm kind of doing a side problem here. If I subtract 1/2 from both sides, you can also multiply both sides by 2. If you distribute, what do you get? 2x plus, what's 2 times 1/2? Multiply the numerator and denominators, you get 2 over 2, and 2 over 2 is just 1, and this is still 0. So what I'm trying to show you is that basically x plus 1/2 is the same thing as 2x plus 1. Do the same thing over here. If you said x minus 1/4 equals 0, let's just say you want to clear the fraction, I'm going to multiply by what number? 4. This will give you 4x minus 1 equals 0. So you can change this one to be 4x minus 1. So here is our polynomial given that information. Either of these answers in orange is acceptable. Probably the bottom one is preferred because you're going to see that more often. So to review, take your x-intercepts, substitute those informations in, put in your y-intercepts, solve for a, put it back in, and then if you have no fractions, that looks better.